Hi and welcome to the 2-Minute Guru. My name is Daniel Bogdanoff. Today we're going to talk about noise. Not audible noise, but electrical noise. What it is and how you measure it. Shush. So today we're going to talk about noise, and what noise is a deviation above or below where your signal should actually be. Random noise is what we're going to talk about today, and it's the most common type of noise. It's present in every system. The first thing you need to know about random noise is it's random, and it's going to follow a Gaussian distribution. So to measure it, you first want to zoom in to the smallest voltage per division setting on your oscilloscope, and then you want to turn on an AC RMS measurement. Why wouldn't I just use peak-to-peak voltage instead of AC RMS voltage? Well, peak-to-peak voltage is not an accurate way to measure noise because it's a Gaussian distributed waveform. So the more captures you have, the higher and higher your noise is going to get because you're going to get lucky and hit farther and farther out on that tail. The other thing you should know about noise is it's distributed by frequency as well. So let's measure noise at 1.5 gigahertz and then turn on the bandwidth limit and see what our AC RMS noise looks like with a 20 megahertz bandwidth limit. So here you can see I've done about 8,500 captures. My average noise is about 396 microvolts, and my standard deviation is 2 microvolts. So let's go ahead and turn on bandwidth limiting and see what this looks like at 20 megahertz. I'm going to select channel 1 bandwidth limit. So you can see after a little over 10,000 captures, my average noise, RMS, is about 236 microvolts, and my standard deviation is still right about the same at about 1.9 microvolts. It's also worth noting there's a lot of factors that play into noise. So your board, your probes, your scope, whether you warmed it up or not, those are all going to affect your noise measurements. Now, noise is also not always exclusively random. There's always going to be a random component, but the environment that you're working in can also introduce noise into your system. So that's this week's episode of the 2-Minute Guru. Be sure to tune in next week and see what environmental factors can inject noise into your system. Subscribe to the Keysight Oscilloscopes YouTube channel. Hit me up on Twitter, like our Facebook page, and I will see you next week. Thanks for watching.